Welcome everyone to Digital Learning by the Department of Collegiate Education. I am Manjunath CV, working as Assistant Professor at Government First Grade College, CS Pura. I am today in front of you to help you solve problems on regression analysis. This is session number 16 and this is the last session for this chapter number 2, regression analysis. Right from beginning in this chapter, we have tried to understand all the theoretical concepts required to solve problems on regression analysis. Later on, we understood what is regression coefficients. Then we proceeded to understanding the regression equations. Further, we solved problems using the actual mean method and assumed mean method. And finally, we looked into few more problems on what could be asked in the examinations, the pattern of the questions, and almost everything related to this chapter. So I hope by the end of this session you should be in a position to clearly understand regression analysis chapter and solve any kind of questions. So regression analysis is in the subject quantitative analysis 2. This is session 16 of the chapter regression analysis. Till now, we have completed 7 sessions, which includes all the theoretical aspects of regression analysis, and we have computed the regression coefficients, which is bxy and byx. Then we have calculated the regression equations from actual mean and assumed mean, and we have covered all these theoretical aspects. So this is the last session, and let us look into one problem which will cover all the topics. So problem 1, from the following data given below, find 1. The regression coefficients. The regression coefficients are bxy and byx. Bxy is the regression coefficient of x on y and byx is the regression coefficient of y on x. Second, obtain the regression equations of x on y and y on x. Now, when we obtain the regression equations, we need to look into our given data and whether we need to decide whether this can be solved using actual mean or assumed mean. When the question is silent and does not mention about whether it should be solved through actual mean or assumed mean, it is left to the student's choice to decide any one method. Generally, what do is when the mean is a complete number, we follow the actual mean method. Third, the coefficient of correlation. They're also asking us to calculate R between the marks in statistics and the marks in mathematics. And finally, the most likely marks in mathematics when marks in statistics are 30. Therefore, here statistics marks are already pre-decided. This is an independent variable and mathematics will be the dependent variable. So for a small change in the marks of statistics, we are going to find out what is the impact on marks in mathematics. This identification of the relationship is nothing but regression analysis. So they have given us the following data about marks in statistics and marks in mathematics. Now let us try to solve the problem. Solution. And we all know step number 1, which is calculation of the mean or the average of x, which is x bar, and y, that is y bar. Let x represent the marks in statistics and let y represent the marks in mathematics. Now we have that decided x to indicate marks in stats and y to indicate in mathematics. Let us go to calculating the mean, which is the first step. Therefore, x bar is equal to sigma x divided by n. and y bar is equal to sigma y divided by n. Now the total of all the values of x gives us sigma x, 25 plus 28 plus 35 plus 32, 31, 36, 29, 38, 34 and 32. Therefore sigma x is equal to 320. And similarly, when we add all the values of y, we get sigma y. 43 plus 46, 49, 41, 36, 32, 31, 30, 33, 39. Sigma y is equal to 380. Mean is equal to sigma x, which is 320, divided by the number of observations. N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Therefore n is equal to 10 and x bar is equal to 32. Therefore mean of x bar is 32. Similarly, y bar is equal to sigma y, which is 380, divided by n, 10. Y bar is equal to 38. So we have got our first step calculation of x bar and y bar. And since both x bar and y bar are complete numbers, let us solve this problem using the actual mean method. So before proceeding to step 2, that is calculation of bxy and byx, we need to find out the values of sigma x square, values of sigma y square and sigma xy. Now x is the deviation of x from x bar and y is the deviation of y from y bar. So x bar is 32, which is x minus 32, and y bar is 38, therefore y minus 38. Now 25 minus 32 minus 7, 28 minus 32 minus 4, 35 minus 32 plus 3, 32 minus 32 0, 31 minus 32 minus 1, 36 minus 32 plus 4, 29 minus 32 minus 3, 38 minus 32 plus 6, 34 minus 32 plus 2, 32 minus 32 0. Y minus y bar, that is y minus 38. 43 minus 38 5, 46 minus 38 8, 49 minus 38 plus 11, 41 minus 38 plus 3, 36 minus 38 minus 02, 32 minus 38 minus 06, 31 minus 38 minus 7, 30 minus 38 minus 8, 33 minus 38 minus 5, 39 minus 38 plus 1. Now let us find the deviations of x and y and square their deviations, x square, y square, and finally find out the product of x and y. 7 squares 49, 8 squares 4 squares 16, 3 squares 9, 0, 1 squares 1, 4 squares 16, 3 squares 9, 6 squares 36, 2 squares 4, 0 squares 0. 5 squares 25, 8 squares 64, 11 squares 121, 3 squares 9, 2 squares 4, 6 squares 36, 7 squares 49, 8 squares 64, 5 squares 25, 1 squares 1. Now when we add all these values, what is sigma x square? 49 plus 16, 9, 1, 16, 9, 36, 4. Sigma x square is 140. Similarly, sigma y square is the total of all the values of y, which is 398. So we found out sigma x square and sigma y square. Now let us find out what is xy. Minus 7 into plus 5 minus into plus minus, 7 5s are 35. Minus 4 into plus 8 minus 32. 3 11s are 33. 0 into 3 0, minus 1 into minus 2, plus 2, plus 4 into minus 6, minus 24, minus 3 into minus 7, plus 21, plus 6 into minus 8, minus 48, plus 2 into minus 5, minus 10, 0 into 1, 0. Now when we add and subtract all these values, what do we get? So 21 plus 2 plus 33 minus 35 minus 32 minus 24 minus 48 minus 10. So sigma xy is minus 93. We have got all these values. Next, let's proceed to step number 2, which is calculation of the regression coefficients bxy and byx. Let us proceed to step 2, calculation of the regression coefficients of x on y and regression coefficient of y on x, which is step number 2. So bxy is equal to sigma xy divided by sigma y square. Bxy is equal to sigma xy. The value of sigma xy is minus 93 divided by sigma y square. It is 398. Therefore bxy is equal to 93 divided by 398, which is 0.2336. Similarly, byx is equal to sigma xy, that is minus 93 divided by sigma x square, which is 140. Therefore bxy is equal to 93 divided by byx is equal to 93 divided by 140, which is 0.664. byx is equal to 0.642. Step number 3, obtaining the regression equations of x on y and regression equation of y on x. X minus x bar is equal to bxy into y minus y bar. X minus x bar, that is x minus 32, is equal to bxy, which is minus 0.2336 into y minus y bar, which is 38. X minus 32 is equal to minus 0.236 y minus into minus plus 0.2336 into 38, which is 8.8768. X is equal to minus 0.2336 y plus 8.8768. Minus 32, when it comes to right side, it becomes plus 32. Therefore x is equal to minus 0.2336 y plus 40.8768. Therefore the regression equation of x on y, x is equal to minus 0.2336 y plus 40.8768. Similarly, let us find out the regression equation of y on x. The regression equation of y on x will be y minus y bar, y minus 38. It is equal to byx, which is minus 0.6642 into x minus x bar, that is x minus 32. Y minus 38 is equal to minus 0.6642x minus into minus plus 32 into 0.6642, which is 21.2544. Y is equal to minus 0.6642x plus 21.2544 minus 38, when it comes to right side, becomes plus 38. Y is equal to minus 0.6642x plus 38 plus 21.2544, which is 59.2544. Therefore the regression equation of y on x is equal to 59.2544 minus 0.6642x. This is the regression equation of y on x. So till now we have computed two things. One is the regression coefficients. The second is regression equations. Next, let us proceed and find out the coefficient of correlation between the marks in statistics and marks in mathematics. The coefficient of correlation R is equal to square root of bxy into byx. R is equal to square root of bxy, which is minus 0.2336, into byx, which is minus 0.6642. R is equal to the square root of minus into minus becomes plus 0.2336 into 0.6642, which is 0.1551. R is equal to 0.3939. So this is the coefficient of correlation. So therefore, the coefficient of correlation between the marks in statistics and the marks in mathematics is 0.3939. And finally, they have also asked us to find out the most likely marks in mathematics when the marks in statistics is 30. Therefore, we have to find out the value of one variable, that is maths is unknown. This unknown variable is called as the dependent variable. When the value of another variable is known, that is statistics is known, therefore this is called as the independent variable. Now, statistics is represented by x and mathematics is represented by y. Therefore, when the value of x is given, which is 30, we have to find out the value of y. Hence, we have to obtain the regression equation of y on x. The regression equation of y on x is y is equal to 59.2544 minus 0.6642x. Y is equal to 59.2544 minus 0.6642 into the value of x here is 30. Y is equal to 59.2544 minus 30 into 0.6642, which is 19.926. Therefore, y is equal to 39.3284. In other words, therefore y is equal to roughly around 39 marks. So the marks in statistics is 30. The marks in mathematics is most likely to be 39. So this is how we find out the various questions asked in our regression analysis. Till now, we have completed the entire chapter of regression analysis, and we have tried to solve different types of problems in this chapter. So let us try to recap what all have we tried to solve in the form of problems. So the very first thing that we tried to find out is the regression coefficients. Now, what are these regression coefficients? These regression coefficients depends on the regression lines. There are two regression lines. One is the regression line of x on y, and the other one regression line of equation of y on x. Since there are two regression lines, similarly there are two regression coefficients. There are two regression coefficients. One is the regression coefficient of x on y, and the other one is the regression coefficient of y on x. The regression coefficient of x on y is called as bxy, and regression coefficient of y on x is given by byx. There are two different formulas to find out bxy and byx depending on the information that they have given us in the question. So the first one says bxy is equal to sigma xy divided by sigma y square, and byx is equal to sigma xy divided by sigma x square. Now this is applicable when we are trying to find out the regression equations from the actual mean. Now what happens when we are using assumed mean? That is when we solve problems from the assumed mean method. Bxy is equal to n sigma dx dy minus sigma dx into sigma dy divided by n sigma dy square minus sigma dy the whole square. This was the regression equation of x on y, the regression coefficient of x on y. And similarly, the regression coefficient of y on x is equal to n sigma dx dy minus sigma dx into sigma dy divided by n sigma dx square minus sigma dx the whole square. So like this, we first find out what are our regression coefficients. Now let's find out the second one, obtaining the regression equations from the actual mean. In case of regression equations, again we have two regression equations. One is the regression equation of x on y and the other one is the regression equation of y on x. So in case of obtaining regression equations from actual mean, we find out what is x bar and what is y bar. Further, we can also solve these regression equations using the assumed mean. In case of assumed mean, we use A as the assumed mean for x series and B as the assumed mean for y series. Further, we also calculated the correlation coefficient from the regression equations, that is r is equal to square root of bxy into byx. Correlation coefficient from the regression coefficients, that is bxy and byx. Next, we found out the value of unknown variable, that is the dependent variable, for a given change in the value of a known variable, which is the independent variable. The independent variable is the value of the known variable, whereas the dependent value is nothing but an unknown variable. So we can find out the unknown value from the known value of an independent variable. So these are the different concepts which we have covered under the chapter regression analysis. And these questions could be either asked individually. For instance, the calculation of regression coefficients could be asked either for 2 marks or for 5 marks or even for 7 or 8 marks. And when combined together, regression coefficients and the regression equations, they can be asked for 8 marks, 10 marks or 15 marks. Further, they can add on to find out the value of dependent when they have given the independent variable. So this is how we solve different problems on regression equations. So with the help of this, I hope you have thoroughly understood the entire chapter. Thank you all.